In 2024, over 970 million registered voters participated in India's democratic elections. That is almost a billion individual minds organizing around a single massive logistical exercise. They are supported by an immense physical infrastructure. The Indian Railways employs over 1.2 million people to operate a network of tracks long enough to wrap entirely around the Earth 1.5 times. When these populations gather for religious events like the Kumbh Mela, millions of devotees cluster tightly enough along the riverbanks that the resulting density is clearly visible to satellites in orbit. And this population is now looking outward, actively landing machines like the Chandrayaan-3 spacecraft on the surface of the moon. Building a system capable of coordinating a billion humans, maintaining global infrastructure, and reaching the moon requires an astronomical level of complexity. To understand how a planet goes from scattered atoms to something this highly engineered, human history is too short of a timeline. We have to look at billions of years of biological research and development. If we rewind the clock far past the first civilizations, past the dinosaurs, and past the first crawling land animals, we eventually arrive at a dark, lifeless, and highly toxic primordial ocean. Roughly 3.5 billion years ago, the first living beings emerged in this harsh, oxygen-free environment. These were unicellular prokaryotes, microscopic, single-celled organisms surviving entirely on simple organic molecules. This chart shows the timeline of Earth's atmospheric composition. For a long time, the line is totally flat, but roughly 3 billion years ago, a group of microorganisms called cyanobacteria developed the ability to photosynthesize. They began converting sunlight into energy, and their byproduct, oxygen, rapidly flooded the atmosphere. With this sudden influx of chemical energy, life could afford to build bigger structures. We see the emergence of eukaryotic cells, cells that contain a distinct nucleus and internal specialized compartments. Instead of operating entirely alone, these individual cells began grouping together into colonies. Over millions of years, these colonies specialized into true multicellular organisms, eventually taking the form of early marine life, like simple sponges, worms, and jellyfish. By capturing the energy of the sun, life established a massive surplus of chemical energy. The planet now possessed the fuel necessary to support large, complex anatomy. Around 540 million years ago, this biological foundation triggered the Cambrian explosion. In a sudden geological timeframe, ocean life rapidly multiplied, mutating and differentiating into most of the major animal groups we recognize today. Early mollusks and arthropods appeared. Fish developed distinct backbones. Eventually, a few of these vertebrates developed specialized fins and lungs, allowing the first amphibians to crawl out of the water and breathe atmospheric oxygen directly. This adaptation led to the age of reptiles, an era spanning over 200 million years, where massive dinosaurs dominated global ecosystems. When an asteroid impact caused their extinction roughly 65 million years ago, it left a vacuum for early mammals to diversify into thousands of new forms, from bats to elephants. This vast fossil record demonstrates a clear biological mechanism. Life actively mutates, specializes, and scales its own anatomy to conquer every available physical environment on the planet. Between 2 and 6 million years ago, early hominids like Australopithecus appeared on the African continent. Over the next few million years, these populations underwent gradual biological modifications, developing larger cranial capacities and walking fully upright as Homo erectus, and eventually modern Homo sapiens. But then, early humans began utilizing external elements. They harnessed fire for cooking, shaped rocks into sharp tools, and learned to plant crops in predictable cycles. Instead of taking hundreds of thousands of years to grow thicker fur for the cold or sharper claws for hunting, humans could simply wear animal hides and carve spears. They no longer had to wait for biological mutations to catch up to their needs. Evolution detached from a strictly biological timeline. It became a high-speed cultural process, allowing early humans to modify their environment in real time. By 3300 BCE, this cultural evolution resulted in the Indus Valley Civilization. Humans were now organizing themselves into structured cities with precise brick grids and sanitation systems, maintaining a continuous, complex society over thousands of years. They also began building invisible architecture. The ancient mathematician Aryabhata introduced the numerical concept of zero. This abstraction provided the mathematical framework required for advanced calculations, commerce, and engineering. This pursuit of abstraction extended inward as well, leading to the systematization of mental and physical disciplines, like yoga, which originated in the region to help individuals navigate their own internal psychology. Human development shifted away from immediate environmental reaction and toward the construction of abstract systems. These mathematical and spiritual frameworks could coordinate the behavior and thoughts of millions of people simultaneously. Today, modern India serves as a massive canvas for this ongoing adaptation. The country spans from the freezing peaks of the Himalayas to the arid, sprawling sand dunes of the Thar Desert. Across these diverse environments, human logistics act like a giant, highly specialized multicellular organism. Through sweeping national initiatives, this network currently produces over 22% of the entire global milk supply, and the physical boundaries of the planet are no longer the limit. The technological adaptation that started with stone tools is now plotting trajectories to the lunar South Pole. The process of evolution has not stopped. The global population is actively adapting to shifting climate patterns, extreme weather events, and the heavy impact of industrialization. From a single cell absorbing sunlight in a toxic ocean to 1 billion people participating in a national election, life is an accelerating curve of complexity. By looking at modern human society, we are watching the current edge of that curve, holding the tools to write exactly what happens next.